Hello and welcome to this short video on revising research design or experimental design in psychology. Research design, not to be confused with research methods. If they ask you about the research design, they're not asking about whether it's a lab experiment or a field experiment or an observation. They're asking about how it's set up. More on that in a second. And also not to be confused with sampling methods, although it is about the participants. This isn't about how you obtain the participants to begin with, but more what you do with them while you're researching. So experimental design refers to how once you've received your participants, and we will talk about sampling in another video, once you've got your participants, how do you allocate them to the different conditions in the experiment? By conditions, we mean the different levels of the IV. So the most common way to design a psychology experiment or a piece of research is to have an experimental group and a control group. So for instance, you might be looking at whether drinking coffee improves memory. So you might give a whole bunch of people a memory test, and then you then have to decide, are you going to give the same people a memory test loaded with coffee, or are you going to use a different group of people to do the memory test with a bunch of coffee? And there are strengths and weaknesses to doing these two different things, and you need to know those. So you might have 10 participants, and you might decide all 10 will take the memory test, and then they will take a separate memory test after drinking coffee. Or you could take your 10 participants, and 5 of them could do the memory test with coffee, and 5 of them could do without. Now, in some cases, whether or not you decide to do it one way or the other will be decided for you because of the nature of what you're studying. But in other cases, this will be something that you have to decide, and therefore you need to know the pros and cons, the strengths and weaknesses of each design. The 3 designs that you need to know for your exam are independent groups, repeated measures, and matched pairs. Or as this handy mnemonic says, I get really mad matching penguins. I'm not sure how helpful that is. I don't know if you've ever tried to match penguins. They all look the same to me. But hey. So, the first one that you need to know is independent groups. And this is where you use different participants for each of the conditions of your IV. So this will be one group of people does a memory test with coffee, and a completely different group of people will do the memory test without coffee. This should be done using random allocation, which means that every participant has an equal chance of being either in the coffee group or the non-coffee group. An example of this might be Zimbardo's Stanford Prison study, where he took his participants and he then randomly allocated whether or not they would become a prisoner or a prison guard. The reason why this is important is you want to be sure that any results that you find happened because of the IV, whether or not they were a prisoner or a prison guard, and not for some other reasons. So random allocation is important and should always be used when using independent measures. Okay, so there's some advantages to using independent groups. You can use the same stimulus material. So in our coffee and memory experiment, you can use the same memory experiment, which is an advantage because then that doesn't become a variable that one test was harder than another. And crucially, there are no order effects. We'll talk about them more in a second. But because they only take the test once, there is no chance that they might get better through practice at taking a separate memory test. So that's a real advantage to the independent group's design. However, the big issue here is participant variables. Because you've got 2 separate groups, you do not know that the nature of those people, which is what we call participant variables, are not the thing that's causing the change. So, for instance, by chance, you may put people with better memories in the group that are drinking coffee. When they perform better on the test, you now don't know whether it was the coffee that made them do better or the fact that because they as individuals have better memories. Now, random allocation tries to get round some of those issues, but it can't get round all of them. So any variations in the groups of people can become a confounding variable, and therefore that's a real weakness of using independent groups. Another weakness is that you will need twice as many participants because you need to create two groups. And if you're doing a study that might be hard to get participants for, particularly if it involves some ethical issues, then that's a problem. Alternatively, you can use repeated measures. So in this one, you use the same participants in both conditions. So you get them all to take the memory test and then all to take the memory test whilst drinking coffee. Now, this is where we come across our old friend counterbalancing. If random allocation is the way to do independent groups properly, then counterbalancing is the way to do repeated measures properly. I'll come back to counterbalancing in a second. So the strengths and weaknesses of using repeated measures. Well, they are basically the opposite of the last set. So the real strength is there are no participant variables because you're using the same people in both conditions. So if they do better on the coffee side of the experiment, because we know their memory is the same, then the coffee must be the independent variable. And likewise, the strength is you need fewer participants than you do with independent groups, which if you're struggling to get participants can be a real bonus. However, the big problem here is order effects. Because you're asking everybody to do the test twice, then they may get better at it the second time because they've practiced it. Or they may get worse at it the second time because they may be tired or bored, what's called the fatigue effect. So this is a massive problem with order effects. Now this can be controlled slightly using counterbalancing. And in counterbalancing, you may remember we talked about this in the lesson. We use the old ABBA example. You split your group into two halves. So one half of the group do experimental condition A followed by B, and the others do B followed by A. Do you see ABBA? Get it? Yeah. So one half of your group will take the memory test without coffee, and then they will take it with coffee. And the other half will take it with coffee and then take it without. Now, crucially, counterbalancing does not get rid of order effects. It just balances them out across the two. So hopefully, by the end of it, the two will weigh each other out, and any differences you find will be down to the independent variable, in this case drinking coffee, rather than the order effects. Does that make sense? I hope. So half of your group will do, if there are order effects, will do better at group doing it the second time, and for them it will be condition B. The other half, if they do better at it the second time, will do better in condition A. The two will then balance each other out, and any difference you're left with is down to the independent variable. Finally, the other problem with repeated measures is you may need extra materials. So in the case of a word memory test, you're going to need a separate set of lists because they've already done one the first time, and the order effects would be ridiculous if you gave them the same test to do again. Of course they're going to do better at it. The final research design that you need to know is matched pairs. In matched pairs, you take your participants and then you try and match them in some key variable or other. Now, you can't match them exactly, but you try and pick whatever you think is going to be an issue. So if, for instance, you're studying memory and you think age is going to be an issue because memory deteriorates with age, you you split them and you go, okay, there's an 80-year-old here and an 80-year-old here. We will match them across the two groups. Matched pairs is basically independent groups. They're two separate groups of people. However, you have tried to make them similar in their makeup, so it's a bit better. Of course, like independent groups, once you've matched your pair, your two 80-year-olds, you then randomly assign one to the experimental group and the other to the control group. You don't pick who goes into which, you draw lots. Hopefully, matched pairs reduces participant variables because you tried to pair them on whatever you think is going to be important. And crucially, like independent groups, there'll be no order effects because a different group of people are taking the test. So they're only ever doing the task once, and you're hoping that if you've matched them properly, your variable of age won't matter anymore. It is very time consuming to do, and to be honest, the major problem is you're never going to match people perfectly. Even if you used monozygotic twins, identical twins, who share 100% of the DNA with each other, there are going to be differences between them. And for that reason, you're still going to have some participant variables. It doesn't get rid of them, it just reduces the participant variables. So matched pairs is arguably better than independent groups, but realistically, you wouldn't use it unless you believe that a particular variable is going to become confounding. Classically, you'd use matched pairs if you were looking at, say, psychological disorders, and you were looking at, say, depression. Now, not everybody is depressed to the same extent. Some people have worse depression than others. So if you're doing a test to say how good a therapy is at treating depression, you're going to have some people get the therapy and some people would get a different therapy or no therapy whatsoever. Now, you want to make sure that across those two groups, you've split the most severe depressive cases and the least severe. So you don't end up with all the most severe depressed people in the group that don't receive the therapy, because it will skew the results and make it look like the therapy is either brilliant or doesn't work at all. So you try and match them across the two, and therefore, hopefully, if one group does better than the other, it's down to the IV, like the therapy they've received, and not because one group were just more depressed than the others. Okay, so they're the three designs that you need to know. You need to make sure that you can spot these, and I will be putting a little test up for you to do that. So the three groups are, or the three designs are, independent groups, different people, repeated measures, same people, and matched pairs, similar people. That's the easiest way to remember it. Different, same, similar. Other key terms that you need to know: counterbalancing, which is used to try and make repeated measures better. Random allocation, which is used to try and make independent groups and matched pairs better. You need to know order effects, such as the practice effect and the fatigue effect. Okay, they're the key terms. Hopefully you found this interesting / useful, one or the other. If you got any questions, please ask. Ta-ta for now.